Well, pre-calculus classes, good morning, good afternoon, or good evening. Today we're going to look at a specific component in section 1.3, which is called the difference quotient. It's something that actually next year, if you do go on to take calculus, you'll go on to something a little bit further involving derivatives and some limits and things that this kind of builds into. So, but again, the difference quotient is f of x plus h minus f of x all over h. And so one of the things that does show up here is, we've done some function work with plugging in variable quantities, and that was to lead into this. We will not make you ever memorize this. This is something that on quizzes and tests you will be given. You'll just have to be able to use this. So, we'll do a couple examples. One fairly simple, one will be a little bit more advanced. But if you're asked to find and simplify the difference quotient for f of x equals 2x minus 9, I actually like to write the actual quotient out as I set these up. So the first thing that we're going to do is the f of x plus h. So anywhere there is an x, we are going to plug in the x plus h. And then we're going to subtract the original function. I always like to put that in parentheses. If nothing else, it helps out with kind of keeping track of like terms when you distribute that negative. So from here, what we're going to do now, distribute the 2. So 2x plus 2h minus 9 minus 2x minus negative 9 becomes plus all over h. Now, you usually have kind of a way to check and see, did we do this correctly? If you have every term that does not have an h in the numerator should cancel. You can see the 2x's cancel, the 9's cancel, and that leaves us with 2h over h, which is 2. So again, there's kind of a nice lead-in to the difference quotient. We will look at one other example with a quadratic. Again, find and simplify difference quotient for f of x equals x squared minus 4x plus 7. So again, I am going to write out the actual quotient itself. And so now, again, this one's a little different because we are going to have to write in x plus h in two spots. So x plus h squared minus 4 times x plus h plus 7. Then we will subtract off the original function. All right, so as far as what we're going to have to do here is FOIL. So I'll go ahead and actually write that. So we have x squared plus hx plus hx. H times h is h squared minus 4x minus 4h plus 7. So you can see when it's a quadratic, it is a little bit more involved. Minus x squared plus 4x minus 7 all over h. So the x squareds will cancel, the 4x's will cancel, and the 7's will cancel. So that leaves us hx plus hx is 2hx. So I'm going to actually cancel or cross that out, plus h squared minus 4h all over h. Now, unlike this last one up here where we had the 2h over h, was nice and easy, just cancel there. Do not actually cancel the h's here. These terms all have an h. That's what I was saying up above. Everything that does not have an h should cancel if you have done these correctly. So the only things that were left, hx's, h squared, and a 4h. Well, we actually have to, or I like to actually factor out an h from everything. So 2x h minus 4 all over h. Now those cancel and it leaves 2x plus h minus 4. So again, like I was saying, next year, if you do take calculus with Coach Lilligren, she'll go over a little more in depth the idea of what is a derivative and also limits, which is what this leads into. But this at least kind of gives you some foundation for future math courses.